In this video, we are going to discuss perimeters and areas of polygons. Specifically, we will recall the formulas of the areas of polygons and later on determine the areas and perimeters of similar polygons. We are going to solve some problems in a separate video. So let's recall what perimeter is. We use the lowercase letter p to symbolize it, and we know that the perimeter of polygons is equal to the sum of the lengths of the polygon sides. So in this polygon here, for example, if we want to get its perimeter, we will have to measure the lengths of each side and add them up. On the other hand, the area of polygons is symbolized by the uppercase A and is the number of square units contained in the region of the polygon. To illustrate, in our polygon here, we have to count the number of unit squares, including fractions of it, to get its area. We will further delve on the perimeter and areas of polygons in this video. We begin by getting the area of the square. We will not be concerning ourselves with the manual counting of the unit squares bounded by the polygons. Instead, we will be focusing mainly on the formulas and how we can apply them. Should you want to engage in proving such formulas, you may refer to your SOG 8.3.1 and SOG 8.3.2. The area of a square is given by the formula A is equal to S squared, where S is the length of its side. So in our example here, if the length of the side is 2, then the area of the square is 2 squared or 4 square units. We then proceed to the formula for the area of a rectangle. The area of a rectangle is given by the formula base times height. So in this case, the length of our base is 3 units and the length of the height is 2 units. Thus, the area is 3 times 2 or 6 square units. We would also like to determine the formula for the area of a parallelogram. The area of a parallelogram is given by the formula base times height. In this case, since the base still measures 3 units and the height measures 2 units, then the area of the parallelogram is 3 times 2 or 6 square units. The area of a triangle is related to the area of a parallelogram. It is given by the product of the base times height divided by 2. So, if its base measures 4 units and its height measures 2 units, then its area is equal to the product of 4 times 2, which is 8, divided by 2, which is 4 square units. Next, we have the area of the trapezoid. It is given by the formula 1/2 times base 1 plus base 2 times height. So in our trapezoid here, base 1 measures 4 units and base 2 measures 2 units. The height measures 2 units as well. So its area is 1/2 times 4 plus 2 times 2 or 6 square units. We then have the area of regular polygons. It is equal to 1/2 times the length of the apothem times the perimeter of the polygon. If the perimeter of the polygon is not given, you may use the formula P is equal to NS, where N is the number of triangles and S is the length of a side. In this regular polygon, the length of the apothem is 3 and the perimeter is 7. Then the area is equal to 1/2 times the apothem 3 times the perimeter 7, which is 21/2 or 10.5 square units. What is notable in the ratio of perimeters of two similar polygons is that they are the same as the scale factor. What does this mean? Since these two triangles are similar, then their sides are proportional. That means that the ratios of their corresponding sides are equal. The common ratio is called the scale factor. Thus, if the scale factor between these sides is 3/2, for instance, then the ratio between their perimeters is also 3/2. Meanwhile, the ratio of the areas of two similar polygons is the square of the scale factor. So in this example, if the scale factor is 3/2, then the ratio between their areas is 9/4. Thanking again the developers of the GeoGebra app which I used in drawing the illustrations in this video.